Okay, what we're going to be doing today is I'm going to be trying to measure the height of the ceiling in the gym. I've got a tape measure here, and we're going to see how we do. Coach Freeland's going to help us out, so here we go. All right, we're at 6 feet. Let's try again. Got to 6 feet that time. So that's about 5, that was 11 feet up in the air I got. All right, we're at 6, 7, 8.5. We might make it. This is not going to work. Let me get a ladder. If I get a little bit higher on the ladder, I might be able to make it to the ceiling. Do not stand above this level. All right, we're at 7 feet. Might actually make it. Nice and easy. This is going to be harder than I thought. We might have to use a different method. Welcome back. This is 7.5 proportional relationships. As you saw in the intro, sometimes there are things that just need to be measured a different way. Surveyors use this. People who do different kinds of measurement for a living will use these kinds of indirect measurement techniques to measure across distances that you may not be able to lay a tape measure across. Okay, and so what we're going to learn about today is a couple of methods of indirect measurement. Okay, so let's talk about this first. Indirect measurement is any method that uses formulas similar figures and or proportions I'm just going to cross that out. Proportions to measure an object. Usually a big object. Okay, and so in example 1, we're going to do an example of indirect measurement, and we're going to use a pineapple that's found in Nambour, Australia. A student wanted to find the height of the statue of a pineapple in Nambour, Australia. She measured the pineapple's shadow and her own shadow. The student's height is 5 feet 4 inches. What is the height of the pineapple? So we're dealing with similar figures here. So basically what she's drawn is she's drawn a triangle using herself as one of the legs and is comparing that to the height of the pineapple as that same leg. The shadow is the shadow that she is casting. The shadow of the pineapple is the shadow of the pineapple is the other shadow she's measuring. So we're assuming, because these are right triangles and the sun is at the same angle, that these two triangles are similar. And so what she's going to do is set up a proportion. So if we look at the proportion, AC, which is her height, over the height of the pineapple. So we're going to compare height to height. That's going to be equal to BC, which is the shadow, over EF, which is also the shadow. When we do this, okay, what we're saying is by angle, angle, these triangles are similar. So by angle, angle, these triangles are similar. So these proportions should be equal. Okay? So if we fill in what we know, AC, so we know how tall she is. She is 5'4". And DF is the height of the pineapple, which we don't know. Here's a picture of the giant pineapple, by the way. You can see these people at the bottom. So it's pretty tall. And then we're going to compare that to BC, 2 feet, over 8 foot 9 inches. Here's part of the problem. Part of the problem is we're dealing with feet and inches. So let's convert these. This is going to be 64 inches over X number of inches is equal to 24 inches over 105 inches. One of the hardest skills to master with similar triangles is dealing with which ratios go with which. So when we solve this, we get 24x equals 280. Oops, nope. That's the final answer. 24x equals 64 times 105. And so x is going to be equal to 280 inches. Okay, and that's 23 feet 4 inches when we divide by 12. That's a method of indirect measurement. So all we did was we set up the shadow to the height, and we used that ratio to try to figure out what the height of the pineapple was. So you're going to do a similar thing in example 1.5. In example 1.5, you're going to take a student who's 5'6", who casts a 5-foot shadow, and compare that to a flagpole that's casting a shadow of 14 feet 2 inches. So go ahead and do that one and use that as an example. Use the previous as an example to figure out this one. We're going to talk about scale drawing. A scale drawing represents an object that is larger or smaller than actual size. So if it's larger or smaller than actual size, what we're talking about is something that represents the size of an object. And if it's a scale drawing, it's the same proportion for the distances. So if you're saying, like on a map, that an inch equals 300 feet, it's going to be like that whether it's height or width or anything like that. The scale is the ratio of any length in the drawing to the corresponding actual length. Now some of you may be thinking scale drawing would be a drawing of a scale like this. That is not true. A scale drawing is usually a smaller version of something that's actually actual sized. The most common example of this is a map, and so that's what we're going to do in this. The scale of this map is 1.5 centimeters equals 300 meters. Now obviously it's going to be a little bit tricky for me to try to show you this as a measurement, but we're gonna go an about see on it. I'm gonna show you kind of how it works. Find the actual distance between Union Station and the Dallas Public Library. Well, when we're doing this, what I'm saying is, here is Union Station over here, okay, and here is Dallas Public Library. Okay, so I want to measure this distance here. Okay, and here's my scale, And so basically what I'm doing is I'm saying how many of these are in this. Well, if I do it about the length, 2, it's about 4. Okay? So if I'm saying that this is about 4, I could use something to measure it. Sometimes if you don't have an actual ruler, you can use just an object and mark the length. Well, if it says 1.5 centimeters to 300 meters, if we actually measure it, we find out that the distance is 6 centimeters on this map. It's actually from your book, so this is 6 centimeters in your book. Well, 6 over x, which is the actual distance, is equal to 1.5 centimeters over 300. Because my scale is 300 meters. See, it's 1.5 to 300, and this is a different way to write that proportion. So 1.5 to 300 is equal to 6 centimeters, which is the distance between these two, if you measured it, to x. Well, when I multiply, I get 1,800 meters. Well, I guess we leave off the units for right now. Is equal to 1.5 times x. Well, when I divide by 1.5, we'll add the units back later, and we get that x is equal to 1,200 meters. They shrink the scale down, like on Google Maps or MapQuest. They shrink the scale down so that they can get more on a page. Well, in this case, they did 1.5 centimeters equals 300 meters. Well, when we measure and find that this is the 6 centimeters here from end to end, one of those centimeters, 1.5 of those centimeters, are 300 meters. And so we just set up the simple proportion. I want you to find the actual distance between City Hall and El Centro College by measuring the distance between City Hall and El Centro. So you're going to find this distance here. See if you can do that. If you've got a ruler at home, that's fine. If not, use the scale and use like the end of your pencil or mark it on a piece of paper and measure that out and figure out how many of them there are to that scale. Okay? So try to do that. If you have big troubles with it, we'll talk about it in class tomorrow. Okay? So that's indirect measurement. And like you saw in the video, sometimes we have to have that. We have to have indirect measurement to measure some of these trickier proportions. Okay? So thanks for watching. We'll see you next time. That was Proportional Relationships.